So last class we talked about the um, currency forward contract. So the purpose of this forward contract is to hedge against currency risk. First, you need to understand why do we need to hedge against exchange rate risk? Well, because if you're a multinational firm, let's say if you're a US firm, and you need to import from Canada, or you need to export to Canada, then you have to think about the exchange rate between US dollars and Canadian dollars. So in this case, this firm, which is a multinational firm, faces the exchange rate risk. So that's why we want to hedge against this exchange rate risk. And the tool we discussed to hedge this kind of risk is the currency forward contract. So put it simply, if a firm enters into a currency forward contract, this basically means the firm has a fixed exchange rate in the future, right? So it's actually quite simple conceptually. And then we discussed how to price the currency forward. And you need to understand how this formula works. So basically it says the forward exchange rate is related to the spot exchange rate. And this relation is determined by interest rate differentials. And then we also talk about this cash and carry method to hedge against currency risk. It's a three-step process, right? You will first borrow, and then you will do the exchange, and then you will invest. So, where is this slide? So it's important for you to understand how this three-step process works. And the best way to understand this three-step process is to solve this example. Right? Okay, so that's for the last class. And today we talk about the second way to hedge against the currency risk, that is, hedge with options. This is quite expected, right? Because when we talk about how the firm could hedge against the commodity price risk, we discussed the futures contract, and we also discussed this option contract. So it's actually similar in the currency case. So let's say this example here. Let's say it is April, and the forward exchange rate for September is 1.038 USD per CAD. And instead of using a forward contract, the firm which needs Canadian dollars in September can buy a call option on the CAD. So basically we're talking about the second method, right? Using options to hedge against currency risk. So let's say the firm decides to buy a call option. And this call option is based on Canadian dollars. And it has a strike price of 1.035 USD per CAD. And it has a price that is 0.0255 US dollars per contract. And this call is written on 1 Canadian dollars. So let's recall what we have learned about call options. We know that if price is larger than this call option, then the call option holder will exercise this call, right? And it will buy the asset at the strike price. So basically, the call option holder exercise the call and pay the strike price to get the asset. If the market price is smaller than the strike price, then the holder will just let this call expire because it's cheaper to pay P to buy from the market. So in this case, the holder of the call option will just pay the market price. It's similar in the case of currency option contract. So here, let's say we have this strike price, which is so now the strike price is 1.035 USD per CAD. So basically in this case, you can see that if the spot exchange rate is larger than 1.035, let's say the spot exchange rate is 1.1 USD per Canadian dollars. So this basically means if you exercise the call option, then for 1 Canadian dollars, you just need to pay 1.035 US dollars. If you don't exercise this call and you exchange for CAD from the spot market, then you have to pay the spot exchange rate. That is, you have to pay 1.1 US dollars for 1 Canadian dollar. So in this case, you can see that it's better for the option holder to exercise this call. So basically, to summarize, if the spot exchange rate between USD and CAD is larger than 1.035, the call option holder will exercise the call option and pay 1.035. And then, obviously, you can see that if the spot exchange rate is below this 1.035 strike price, then the option holder will just let the call expire and it will just pay the spot exchange rate instead. Okay, so basically you can see that this table gives us the result we just discussed. So remember the strike price is 1.035 and the premium is per contract 0.0255. Now let's say we have a spot price. Say the market or the spot exchange rate is 0.95. So you can see that in this case it's below this it's below this strike price, right? So in this case, option holder will not exercise the option. So the exchange rate would be 0.95. That is, the option holder will just pay 95 cents of US dollars for 1 Canadian dollar. But this is the call option. So this option holder has paid option premium. And the option premium is given by this number, right? So the total cost for this option holder is the spot exchange rate plus the cost of option, which is 0.9755. And it's similar in the case if the spot exchange rate is just 1. Again, it's below this strike price. So let's see the case when the spot exchange rate is larger than the strike price. And in this case, it's cheaper for this call option holder to exercise the call and to exchange for Canadian dollars at the strike price. So in this case, option will be exercised and the exchange rate would be just the strike price, 1.0350. Again, we should not forget the option premium. So this will increase the option holder's cost. So finally, the actual cost to exchange for Canadian dollars would be the strike price plus the option premium. So it's 1.0605. Okay, so we can summarize what we have discussed in this picture. So let's talk about, or let's compare three cases. So basically you can see that, okay, let's first mark the strike price on this picture. Let me use a black color. So this is the strike price, which is 1.035 USD CAD. So we have three cases. The firm is not hedging, and the firm uses a forward contract to hedge. The third case is the firm uses a call option on Canadian dollars to hedge. So I would say the simplest case is just this forward hedge, right? So if the firm is using a forward contract, let's say the forward contract has a fixed exchange rate of 1.035 USD per CAD. Then you can see that the firms or this option holders cost would be given by this horizontal line. The reason is because it's a forward. It's a forward contract, right? And we know that if it's a forward contract, the exchange rate will be fixed, right? So let's say, let's call this exchange rate as F, right? So F is 1.035. And you can see that no matter what the spot exchange rate will be in the future, the firm will always use this 1.035 exchange rate because of this forward contract, right? So this basically means with a forward contract, this firm's cost of exchanging USD to CAD is fixed. It is always 1.035 USD per CAD. That's why now you have a horizontal line here. Okay, let's talk about the no hedge case. So if there is no hedge, right, then you can see that the firm's cost of exchanging USD for CAD is just equal to the spot exchange rate, right? Which means if the spot exchange rate is 1 USD per CAD, then the firm will just pay 1 USD per CAD. If the spot exchange rate is 1.4, then the firm will just pay 1.4 USD per CAD, right? Which means you will get a 45-degree line like this blue line here. Okay, the last case, the firm uses option to hedge. And in this case, as we just discussed, the firm was using the call option to hedge against the currency risk. In this case, so let's see how the firm's payoff will look like. So let's say we discuss two cases, right? Let's say we denote spot exchange rate as S. And let's say the firm's cost of exchanging USD to CAD is denoted by C, right? Now what you can see here is if the spot exchange rate is larger than the strike price. And we have discussed the firm would just exercise its call, right? So in this case, the firm will exercise its call, and don't forget, there is this call option premium, which is 0.0255. So it's 1.0605. So this means if the spot exchange rate is larger than the strike price, the firm's cost of exchanging the US dollars to the Canadian dollars would be 1.0605. And if it is below this if the spot exchange rate is below this strike price, then the firm's cost would be, well, the firm will just pay the spot exchange rate. But the firm would again consider the option premium, right? Because the firm has to pay option premium to buy the call. So in the end, the firm's cost of exchanging US dollars to Canadian dollars would be the spot exchange rate plus a fixed number, the option premium. So this basically means if you draw this equation, right, it will be a it will be a 45-degree line, but it will have this little distance here, right? So this little distance is exactly the option premium. So that's how you get these three lines. And if you have time, I hope you could sit down and try to see whether you can understand how could you get these three lines. Okay. Now, so we basically talk about two ways for a firm to hedge against currency risk. They are using a forward contract, or the firm could use a option. Now, what kind of difference here, right? Why a firm would choose to hedge with options rather than using a forward contract? Well, the reason is, first, it's quite clear to see that if the firm is using a forward contract, then its cost is fixed, right? It's a horizontal line. And if the firm uses a option contract, then if the exchange rate becomes lower, then you can see that the firm can actually benefit, right? So here, when the exchange rate moves in favor of this firm, you can see that the firm is paying a lower cost of exchanging USD to CAD, right? So that's the benefit of the call option. It gives you this additional benefit if the price moves in your favor. But you can see that this kind of benefit is not free, because you have to pay this option premium to get this benefit. And the second reason is the transaction the firm is trying to hedging might not happen. So in this case, it's better to use an option, because if the transaction fails, the firm can just walk away without exercising this call option. Because we know that if you're a holder of a call option, you have the right to exercise the call, right? You don't have the obligation, so you can just walk away. But this is different for a forward contract. A forward contract is similar to a futures contract. Both parties, either long side or short side, will have the obligation. So in this case, it basically means that even if you're trying to exchanging USD for CAD, let's say your transaction fails in the end. So in the end, you haven't got any US dollars from your customer. In this case, you still have to fulfill this forward contract. You still have to exchange US dollars for Canadian dollars, even if you don't have US dollars, right? So this could be problematic. Okay, this might sound a little confusing. Let's see this example. It will make you understand why a option could be preferred if your transaction might fail in the end. Okay, so let's say this ICTV is a US firm, and it's okay, we have a lot of redundant words here. Developing software for a UK firm, right? And this US firm, ICTV, has just negotiated a 20 million British pound deal with a UK cable operator, Telewest. And we assume the ICTV, the US firm, will receive the payment in 6 months. However, it's possible this deal might fail. The ICTV's executives, they have two major concerns. The first is their engineers might not be able to meet the UK firm's technology requirements. So in this case, the deal will just fail. And second, even if the deal succeeds, the British pound GBP might fall. So in this case, it will reduce the value of US dollars. So basically, you can see that there are two risks here. The first risk is business risk. Right? It's possible that the deal cannot be done. And the second risk is currency risk. That is, even if the deal gets done, the US firm will receive a payment denominated in British pound. And this will generate or make this US firm face exchange rate risk because it's a US firm. Okay, so let's see some additional numbers. Let's say the current spot exchange rate is 1.752 USD per GBP. And the 6-month forward exchange rate is 1.75. And we have a 6-month put option on the British pound with a strike price of 1.75. And the premium for this put option is 5 cents. Now, we need to compare ICTV's outcomes if it does not hedge, and it hedges using a forward contract, or it hedges using a put option. Okay, now let's start with the simple case. Let's say the firm does not hedge. So if the firm does not hedge, then the firm will subject to the exchange rate risk. And the complication in this problem is we have to discuss two cases because we know that it's possible the deal will fail. So we have to examine ICTV's revenue or payoff under these two scenarios. That is, if the deal is successful or if the deal fails. Okay, so let's consider the case. So we are thinking about the case that is ICTV has no hedge. And in this case, let's first consider the deal is successful, right? So if the deal is successful, then you can see that basically the firm ICTV will get $20 million British pound of payment, right? Or you could say the firm ICTV's revenue would be 20 million British pound. And then the firm will need to exchange this 20 million GBP into USD, right? So let's assume the spot exchange rate is S. So basically S means for, okay, let me use a different color. So the spot exchange rate is S. Here basically S means for 1 British pound, you have to pay S US dollars, right? So this means if the firm decides to exchange the 20 million GBP into USD, then the firm's revenue will be 20 times S, the spot exchange rate, million US dollars, right? Again, it's 20 times spot exchange rate, million US dollars, right? So let's say if the deal fails. Now this is simple because if the deal fails, then the US firm will not receive anything. So its revenue is just $0 US dollars, right? So we can draw this result in this picture. Here, the horizontal axis is spot exchange rate S, and the vertical axis is the firm's revenue denominated in US dollars. And the red lines give us the no hedge case. And the red line on the top gives us the case when the deal went through. And you can see that this is a upward sloping straight line. This is easy to understand because according to the equation we got here, right? We know that this line is just revenue equals 20S, right? S again is the spot exchange rate. Of course, if you draw this R equals 20S, in this picture you can see it has to be a upward sloping straight line. And then the red line on the bottom is firm's revenue if the deal fails. So you can see that here R is just 0, right? So this is easy to understand. Okay, now let's see, let's talk about the second case. The second case is the firm decides to hedge using a forward contract. Right, so now we have so here it's the case with a forward contract. Obviously, again, we have to think about these two cases separately, right? Deal went through or deal failed. So if the deal went through, now you can see that the firm has entered into this forward contract, so it will have a fixed exchange rate. And you can see that the forward exchange rate is 1.75, right? So basically you can see that the firm's revenue would be 20 times 1.75 million US dollars, which is just 35 million US dollars. And you can see that the case when the deal went through is very easy, right? Just a simple number, $35 million. But you have to be careful with this case. Okay, the second case, the deal fails. We learned that when the firm does not hedge, if the deal fails, the firm's revenue is just zero. But if the firm hedges with a forward contract, even the deal fails, the firm's revenue will not be zero. Intuitively, it's because the firm has entered the forward contract, and the firm has the contractual obligation to exchange GBP to USD, even if the firm haven't received GBP from the UK firm, right? So now the revenue would be the difference between the forward exchange rate and the spot exchange rate times $20 million. So why do we get this result? Well, intuitively, you can see that the firm ICTV is obligated to exchange 20 million GBP for USD. So it will get this. So it will get, So it will get $35 million of US dollars. However, because the firm does not have British pound, so there is a cost for this 20 million British pound. And the cost is determined by the spot exchange rate. So the cost of the 20 million British pound is given by the spot exchange rate times the total amount, 20 million, right? So basically this is like the cost to the firm. And now what you can see here is if you draw this equation, you can see that it will be a downward sloping line, right? It will be a downward sloping line, and it will have a horizontal intercept at 1.75. So this line is given by R equal to 1.75 minus spot exchange rate times 20. Right? Oh, I forgot to add this note here. So you can see that for this line, it's just $35 million. Okay, now let's discuss the third case. The firm is hedging with a put option. Okay, so first, why the firm wants to use a put option? Well, because you can see that the put option has a strike price of 1.75. This basically means with this put option, the firm can at least exchange GBP for USD at the rate of 1.75, right? Okay, now again, two cases. Let's say the deal went through. In this case, the firm will receive $20 million of GBP, and it will want to exchange this British pound into US dollars. And now the firm has to think about the spot exchange rate versus the strike price. So if the spot exchange rate is larger than the 1.75 strike price, in this case, the firm ICTV will be better to exchange GBP for USD in the open market. So it will just let this put option expire, right? Obviously, the firm will get a better price in the open market. So in this case, the firm's revenue would be the spot exchange rate times 20 minus the option premium. So the option premium is 5 cents per option. And because the firm has 20 million GBP, so it has to buy 20 million put options. This means the total cost of the put option would be 1 million, right? So it's $1 million. Okay. Now, let's assume the spot price is lower compared with the strike price. Well, in this case, the firm will choose to exercise its put option. So the firm will exchange GBP for USD at a rate of 1.75. So the firm will get $35 million. Again, we have to deduct the cost of put options, $1 million, right? So it's 35 minus 1 equals 34. Okay, now let's first mark these lines. So this part is revenue equals 34. And for this line, it's 20s minus 1, right? That is, for this section, it's just revenue equals 34. And for this section, it's given by 20s minus 1. S is just the spot exchange rate. Okay, now what about the case if deal fails? Well, if deal fails, now the firm will not have any GBP to exchange for USD, right? So it will not have British pound. Now, for this case, we will just calculate the firm's payoff from this put option, right? And we learned about this. We understand that we know that if spot rate is larger than the strike price, the firm will not exercise this put option. So this put option will just expire. So the firm's payoff would be 0 minus the cost of put option, $1 million. So it's just a minus 1. If S is smaller than this strike price, then the firm will exercise. In this case, the firm's profit would be given by the strike price minus the market price, that is the spot exchange rate, right? Times 20, because the firm has 20 million put options. So if you mark these lines, then you can see that for this section, it's just revenue equals minus 1. And for this section, it's given by 1.75 minus S times 20. Okay, that's for this problem. You can see that I would say it's not complicated, but it's actually quite long. But it's good exercise for you to understand how do you calculate payoffs from no hedging, from hedging with forward contract, and from hedging with put option. So please spend some time to understand the calculation here. Okay, great. Now we could talk about the interest rate risk. So we basically talk about two kinds of risks, right? Commodity price risk and exchange rate risk. And now the third type of risk we want to focus is the interest rate risk. And you can see that it's important for a firm to hedge against interest rate risk as long as this firm has debt, right? And the firm will care about the interest changes, no matter whether the interest rate increases or decreases. If the interest rate increases, then the firm will suffer because its debt cost of capital will be higher. This means the interest payment will be higher. And this implies the higher interest payment will reduce the firm's EBIT, which reduces the firm's earnings, right? So the second point about the interest rate risk is more subtle. The firm will also suffer if the interest rate decreases. So the logic works like this. Most firms have long-term liabilities, such as a capital lease or some pension fund. And if interest rate decreases, then the decreased interest rate will increase the present value of these liabilities. This will lower the value of the firm. So to understand this, we know that a firm's equity value equals its market value of asset minus its market value of debt. And we know that debt is essentially some discounted value of future liabilities, right? And if interest rate decreases, then the discounted value of these liabilities will increase, which means the firm's equity value will decrease, right? So you can see that a decrease in interest rate will also hurt a firm by decreasing its value of equity. Okay, so to hedge against the interest rate risk, the first step is we want to understand how to measure the interest rate risk. So here the tool we will use is duration. After understanding duration, we will see how we can use this duration hedging technique to minimize a firm's interest rate risk. Okay, first let's define duration. So we will focus on the duration of a bond. So let's say, okay, let's first define these notations. CT, which is the cash flow on date T. And PVCT obviously is just the present value of the bond's cash flows. And this sigma PVCT obviously is the summation, is the total of the present value of the cash flows. And the duration is defined by this formula. So let me explain. So what you can see here is you can consider duration as a weighted average of time t. That is, so duration is a weighted average of time t. Now the question is, what is the weight? Well, the weight is just given by the present value of the cash flow at time t divided by P. Here, P is the present value of the bond. Okay, if it's still confusing, let me give you a example. So let's say we have a bond. And let's say its par value is $100. And it will pay you, let's say, let me make up some numbers. So it will pay you $10 coupon rate at the end of the first year. And it will pay you another $10 coupon at the end of the second year. And this is a 2-year bond, which means after 2 years, you will get the face value, right? So you can see that in this case, C1 is just 10 and C2 is 110. Now what is P? P is the present value of the bond. So let's say the present value of the bond is, let's say it's just, okay, let me make it easy. Let's say the present value of the bond is just $100, right? So in this case, you can see that the duration of this 2-year bond would be given by the first weight times the first year, and the second weight times the second year, right? So the present value of C1, obviously you have to discount C1. So let's say the discount factor, the yield of this bond is 10%, right? And in this case, you will, so I don't exactly know what's the present value of C1, but obviously it's $10 divided by 1.1, right? And then divided by the price of the bond and times 1. And then present value of C2 would be 110 divided by 1.1 squared. And then divided by the price of the bond times 2, right? So you can see that it's pretty easy. So just remember that duration is a weighted average of time t. And for each time t, its weight is given by the present value of the cash flow at t divided by the price of the bond. Okay, now let's see this example here. So we assume the par value is $100. Again, par value basically means when the bond matures, you will get back $100. The first question is, what is the duration of a 10-year zero coupon bond? And the second one is, what is the duration of a 10-year bond with 10% annual coupon trading at par? Okay. The first one is much simpler. So let's first solve the first one. So this is a 10-year zero coupon bond, right? And if you draw out this timeline, then you can see that this is a simple case because in the end, right, you will just have one payment, $100. And for all other years, you won't get any coupon payments, right? So according to our formula, duration equals present value of $100 divided by the price of the bond times 10, right? However, we know that price of the bond equals the discounted value of 100. So you can see that this whole thing is just 1. So the duration is just 10 years. This is a general result. Basically, if you have a 2-year zero coupon bond, then the duration is just a 2 year. Of course, if you have a 30-year zero coupon bond, then the duration is 30 years. Okay, now let's look at the second problem. So the second problem says, what is the duration of a 10-year bond with 10% annual coupon rate trading at par? First, trading at par. What does this mean? So if a bond is trading at par, it means its price equals its face value or par value. So the bond has a price of 100. And second, if a bond is trading at par, this implies its coupon rate equals its yield, which means the yield of the bond would be 10%. Right? And now we can solve the 10-year bond's duration. What you can see here is, if you draw a picture, you can see that this is slightly complicated. So you can see that at each date, we will get $10 coupon bond, coupon payment. And then on the final date, on the maturity date, we will get this $100 par value. So now we have to discount these cash flows, right? And we also have to use this weight times T. That's how we can get our par value. That's how we can get our duration. So if we plug in these numbers, right, the duration would be the first payment of $10 discounted value divided by the bond price, 100, times 1. And then the second would be the second payment divided by 1.1 squared divided by 100 times 2. And you will continue to do this. And for the 9th year, it would be 10 divided by 1.1, 9 divided by 100 times 9. And for the last one, should be 110 divided by 1.1 with a exponential of 10 divided by 100 times 10, right? So you can see that the calculation is somewhat complicated. If you look at the answer here, so let's look at the answer here. What you can see here is clearly it gives you these different steps, right? So if you look at this first row, right? The first row exactly calculates this guy, right? Oops. So exactly calculates this guy. You can verify that you're using the first coupon payment and you discount this first coupon payment at percent rate. So this gives you 9.09. And then you would then you would divide this number by the price of the bond, 100. So this gives you 9.09%. And then times 1, so this gives you this, right? Again, let's try another one. So let's try this guy, 5. So in this case, it would be 10 divided by 1 plus 10%, 5. This gives us 6.21. And next, we would divide this number by 100. So this gives us 6.21%. And times 5. So this gives us 0.31. So in the end, you will get all these numbers and you will add up these numbers together. So this will give you 6.76 years. What you can see here is if it's a bond with coupon payments, then its duration will be smaller than its maturity. And this is the general result. Again, in this problem, we can see that this bond has a 10-year maturity, but its duration is just 6.76. It's smaller than the bond's duration. The general result is if a bond is a coupon bond, that is, it pays coupon before its maturity date, then this coupon bond will have a duration smaller than its maturity. Okay, now why do we want to spend this time to understand duration and to learn how to calculate duration? Well, what you will see is the present value of your cash flows is more sensitive to interest rate changes if these cash flows have longer duration. That is, duration is a measurement of interest rate risk. So cash flows with longer duration will have to suffer from larger interest rate risk. Okay, let's see the measurement here. So let's say the R is the bond yield. That is the APR used to discount cash flows. So let's say the bond yield increases from R to R plus epsilon. So this epsilon is a very small number. And then the present value of the cash flows will change by this. What you can see here is, first, if the APR increases, right? That is, if this epsilon is positive, then you can see that the percentage change in value is negative. It is smaller than 0, right? This is easy to understand because we know that when you discount cash flows, if you're using a larger discount factor, then the present value will be lower, right? And this is a very nice formula because it tells you that given this change, given this epsilon, this small change, if these cash flows have longer duration, then the percentage change in value will be larger, right? Okay, so let's again decompose this formula here. Of course, this guy is just duration. And please don't forget this negative sign. Epsilon is the change in the interest rate or the bond yield. And let's say, for example, if the interest rate increases from 0.1 to 0.11, the epsilon is just 0.01. And here the R, again, is just the bond yield. Okay, K. So K here is the number of compounding period for 1 year. So let's say if you have a bond, let's say if the bond pays annual coupon payment, then this means you will only compound one time per year. So K equals 1. If you have a bond which pays coupon bound every 6 months, then this means you will compound twice per year, right? So you can see that in the case of bond, the number of K is related to the schedule of coupon payments. Again, maybe let me write it here. If it's annual coupon payment, that is, for a bond, if you receive the payment for every 12 months, then K equals 1. If it's semi-annual, then K equals 2. That is, you receive your coupon payments twice per year. So here, K equals 2. Okay, let's say this example here. Suppose the yield of a 10-year bond with 10% annual coupon increase from 10% to 10.25%. Use the duration to estimate the percent price change. That's the first question. The second question is, how does your calculation compare to the actual price change? Well, the first one asks about the percent price change. So clearly, we wanted to use the duration formula. That is, the percent price change equals minus duration times the change in the interest rate divided by 1 plus interest rate times K. Note here we have annual coupon. So this implies K equals 1. And what is R? Well, R is just 10%. So here the R is the initial interest rate. Note that you have two interest rates here, 10% and 10.25%. Don't use 10.25%. You should use the initial one, that is the 10%. Now, what is the change in the interest rate? Well, it's 0.25%. What is the duration? Well, this is a 10-year bond with 10% annual coupon bond. And we just did the calculation, right? Its duration is 6.76 years. So it's 6.76. And now we have all the numbers we need. So we just plug in numbers. 6.76 times 0.25% divided by 1 plus 10%. And this will give us a number of minus 1.53%. So it's minus 1.53%. So this is the value we can get from using this duration formula. And the second one says, how does it compare to the actual price change? Now, how do you find out the actual price change? Well, we know that the present value of the bond is easy to calculate, right? You just need to discount this, the coupon payments of the bond and the par value of the bond. And this is a 10-year bond. So we know that if interest rate increases from 10% to 10.25%, then the price of the present value of the bond would be given by, first we have to discount the coupon payments, and we can use the 10-year annuity formula. So it should be, okay, I have bad memory to memorize this formula. So we would 1 divided by this interest rate, 1 minus 1 plus 10.25%, and we have 10-year, times each period coupon payment. And we also need to discount the final par value. Okay, I'm running out of space. All right, so it's 100 divided by 1 plus 10.5% with the exponential of 10. So in the end, the bond price will decrease to $98.48. This is expected, right? Because originally, when the yield of the bond was 10%, then the present value of the bond was $100. And now the yield has increased from 10% to 10.25%. In this case, the present value of the bond would decrease from 100 to $98.48. So you can see that the change in the price would be the 98.48 minus 100 divided by 100. This will give us a number of minus 1.42. So if you compare these two numbers, you can see they're different, right? Which one is more accurate? Well, this one. Because for this one, we used this discounting formula to exactly calculate the bond price after the interest rate increases, right? So this is the most accurate number. But what about this guy here? Well, this minus 1.53%, it is just a approximate number, right? Because if you look at this lecture note here, it says if the interest rate changes, then the present value of the cash flows will change by approximately, right? So it's a approximate number. That's why you get this approximate sign here, right? But why do we want to use this approximate number? Well, because it's much easier, right? It's easier to use this duration formula to find out the percent change in value compared with this more complicated method. Okay, so we have introduced duration, and we have also understood how value will change if the interest rate changes. And this kind of change will be calculated by using this duration formula. So next class, we will talk about duration-based hedging. That is, we will use what we have learned to understand how could we use this duration neutral technique to hedge against interest rate risk. So that's for today's class.